Problem number 21. Cosecant A minus 1 by cosecant A plus 1 is equal to cos A by 1 plus sin A whole square. Right, LHS we have to take, RHS we can prove. RHS you should observe what terms are there, cos and sin. So here also cosecant we have to change in terms of sin. LHS cosecant A minus 1 by cosecant A plus 1. Cosecant and sine, what is the relation? Both are reciprocals. 1 by sin A minus 1 by 1 by sin A plus 1. What is the LCM here? Numerator and denominator we have to take separate LCMs. Sin A 1 minus sin A by denominator also as it is LCM. Here 1 plus sin A. Here sin A cancel, it will go. Remaining 1 minus sin A by 1 plus sin A. The numerator we have to do rationalizing. Numerator 1 minus sin A. So rationalizing means 1 plus sin A. We have to multiply and divide. 1 plus sin A by 1 plus sin A. Numerator you should multiply. 1 minus sin A into 1 plus sin A by denominator. What formula we can use here? A plus B into here 1 plus sin A, 1 plus sin A, 2 times is there. So 1 plus sin A whole square we can write. Now numerator you should observe A plus B, A minus B, A plus B. Formula we can apply. 1 square minus sin A whole square we can write by 1 plus sin A. Denominator I am not changing. Here 1 square value is 1 minus sin square A by 1 plus sin A whole square. 1 minus sin square. How to write cos square we can write. We are using identity. By 1 plus sin A whole square. Numerator and denominator both have squares. So single square we should write. Cos A by 1 plus sin A whole square. Should observe RHS cos A by 1 plus sin A whole square. We got same answer. RHS. Therefore, LHS equal to RHS. Next problem is 22nd. Tan square A minus tan square B is equal to RHS we have to prove. RHS terms are sin and cos. So left hand side tan A and tan B we have to write in terms of sin and cos. LHS tan square A minus tan square B. Tan A formula sin square A by cos square A minus sin square B minus cos square B. Take LCM. Cos square A, cos square B into here sin square A into cos square B minus sin square B into cos square A. RHS. Denominator cos square A and cos square B. Here cos square A, cos square B. So we don't change denominator. Numerator you should observe. Sin square A minus sin square B. Only sin value we have. Here sin square A, cos square B. Here sin square B, cos square A. So only cos values we have to change here. Sin square A. Cos square B. How to write? We have to use first identity. 1 minus sin square B minus sin square b of 1 minus sin square a by cos square a into cos square b. Here 1 minus sin square b. This bracket we have to multiply with sin square a. Sin square a into 1. Sin square a minus sin square a into sin square b. Sin square a into sin square b. Next bracket we have to multiply with minus sin square b. Minus sin square b, minus into minus, plus sin square a into sin square b by denominator as it is we have to write sin cos square a cos square b. Any cancellations we have? Minus sin square a sin square b plus sin square a sin square b cancel. Remaining terms sin square a minus sin square b, denominator cos square a cos square b. Sin square a minus sin square b by cos square a into cos square b. This is our RHS. Therefore, RHS. Therefore, LHS equal to RHS. Next problem is 23. Here LHS we have to consider and RHS we have to prove. LHS, numerator what is the common? Sin theta, and denominator is cos theta, we have to take common. Sin theta of 1 minus 2 sin square theta divided by, here denominator what is the common? Cos theta. Cos theta of 2 cos square theta minus 1. What is our answer? Tan theta. Tan theta we have to prove. Tan theta means already we got answer. Sin theta by cos theta. Remaining everything we have to do cancel. So sin square theta we have to change in terms of cos. Identity we have to use. 1 minus 2 of sin square theta. 1 minus cos square theta we can write using identity. Cos theta of 2 cos square theta minus 1 is equal to, here sin theta of 1, this bracket we have to multiply with minus 2. Minus 2 into 1, minus 2, here minus into minus, plus 2 into cos square theta, 2 cos square theta by cos theta of 2 cos square theta minus 1. Next numerator 1 minus 2, minus 1 it will come. Sin theta of minus 1 remaining plus 2 cos square theta plus 2 cos square theta. Denominator as it is, we should write cos theta of 2 cos square theta minus 1. 2 cos square theta minus 1. Numerator you should observe 2 cos square theta minus 1. Denominator 2 cos square theta minus 1. Both cancel. Remaining sin theta by cos theta. Sin theta by cos theta value is tan theta. This is RHS. Therefore, LHS equal to RHS. Next problem is 24th problem. Here cos A by 1 minus sin A we have to take. We have to prove secant A plus tan A. LHS we have to consider cos A by 1 minus sin A. Here denominator rationalizing we have to do 1 plus sin A by 1 plus sin A. Numerator you should multiply. Cos A into 1 plus sin A. Cos A of 1 plus sin A. By here formula we have to apply. A minus B into A plus B formula. 1 square minus sin A whole square. Cos A of 1 plus sin A by, Here 1 square value is 1 minus sine square A is equal to 1 minus sine square value. We have to use identity. Cos square we can write cos A of 1 plus sine A by cos square A. Here 1 cos A cancel. Remaining 1 plus sine A by cos A. RHS is secant A plus tan A. We have to split denominator here. 1 by cos A plus sin A by cos A. 1 by cos A. How to write? Secant cos reciprocals. 1 by cos means secant A we can write. Plus sin A by cos A. Value is tan A. Secant A plus tan A. This is RHS. Therefore, LHS equal to RHS. Next problem is 25th one. Here LHS we have to take, RHS we have to find out. Here sin A, here tan A. Tan A we have to write in terms of sin and cos. Sin A into tan A, sin A by cos A divided by 1 minus cos A. Here cos A we have to write in denominator. Here sin A into sin A, sin square A by cos A of 1 minus cos A. Denominator cos terms we have. So numerator also we have to change in terms of cos. Sin square. Sin square how to change cos? Identity we have to use. Sin square is equal to 1 minus cos square. 1 minus cos square by cos A of 1 minus cos A. Numerator I will write 1 square minus cos A whole square. Any changes? No changes here. Cos A of 1 minus cos A. Numerator you should observe A square minus B square formula. We can use here. 1 plus cos A, 1 minus cos A. Denominator as it is you should write cos A of 1 minus cos A. Cos A of 1 minus cos A. Numerator 1 minus cos A, denominator 1 minus cos A cancel. Remaining 1 plus cos A by cos A. Here in terms of secant only is there. So denominator we have to split. 1 by cos A plus cos A by cos A. If you will take LCM, same this answer only it will come. 1 by cos A, secant A we can write plus cos A cancel 1. This is RHS. Therefore, LHS equal to RHS.